Hey guys, Joe Pye here at Advanced Innovations. Welcome back to the shop. You know, I got to say I enjoyed building the little mini lathe that I did recently to a point where I've decided I'm going to build more of, if not the entire machine tool product line offered by PM Research. This is the part that I'm going to start with. I'm not going to tell you which machine this belongs to. It could belong to several. If you think you know which one it's going to be, put it in the comment line below, and we're going to find out either by the end of this video or somewhere in the next 2 or 3. This will not be a 37-part series. This is going to be a very realistic, comfortable, fun little build, and it might be something you might want to consider getting and starting just to build your confidence. Anyway, there's only one way to get started, right? That's to grab the files. I'm going to grab a comfortable chair because this is going to take a while, I know. And let's turn this into something beautiful. Stick around. I used a wide variety of needle files to clean these little castings up. The round files got to work out because they seem to just fit everywhere you want them to fit. Anytime you have a surface that meets another surface at a right angle, naturally a square file is going to do the job. But keep that Sharpie marker handy. It's just as important as a file. All right, this is what it looks like before. And this is a small piece, but there's an awful lot of detail on it. The detail is even harder to take care of if there's a mismatch in the casting. That's what it looks like before, and this is what it looks like after. I'd like to share with you one of my techniques that has proven to be very handy in keeping track of exactly what you're filing. If you're looking to turn something like this into something like this, well, controlling your files, controlling your sander, grinder, whatever you're going to do it with is really important. And I just use a Sharpie marker. You can see the line on the side of this piece that you want to erase. Darken it up. And don't hesitate to do this throughout the entire process as you're doing the part. Let's grab a random file here and just scratch it. There we go. Now, as you pass the file over that surface, you'll get a pretty good feel for exactly where the file is hitting, and you can adjust accordingly. On a raised rib like this, it's relatively easy to do, but when you start getting down into mismatched surfaces, the last thing you want to do is have the file attacking the surface at the wrong angle and remove way too much before it starts to blend. So keep the Sharpie marker handy, keep the magic marker handy, whatever you got to use, Dykem. File it, black it out, keep on filing it, shoot for the moon. Anyone curious about how I get the nice finish on the castings after I'm done filing and sanding on them, that would be this machine right here. This is my blast unit. It's a 48-inch 3-door unit. I use number 6 glass bead in it, set it around 35 pounds. Air pressure, that is. Great way to clean up a casting. There is no shame in taking hours to file a part as simple as this. If you are not pleased as you progress, well, it's okay to step back and get pleased. Removing mismatch like this with a file and still making it look halfway decent can be time consuming, so don't worry about stepping back. Use the black marker that I just showed you for your parting lines and try to blend everything in as nice as you can. It will take time. Be patient, and your effort will be rewarded. Now I'm going to take the legs, I'm going to finish the legs, we're going to put them, actually I have a bunch of them. There's a great reason for that, right? So we got 2 that are done, and 2 that are not. Let's see them side by side. There's a variety of different files on the work. Make sure you get the rounds right, make everything blend. It's going to be pretty. I'm going to put these in a fixture. I'm going to do them at the same time. When I side mill them, I'm going to strap them down, side mill the bottom and the top. That way I know they're identical match pair. And then we'll figure out exactly how they go together on the assembly. Let's go to the mill. For rapid material removal on these parts, I'm going to press them up against the belt sander. I will not sand the entire bottom of the pad off. I'm going to leave a little of the original casting so that I know the removal is symmetrical. I think it's safe to say that when you make a fixture, don't throw the fixture away. Put it on the shelf and use it as you need to. This is the fixture that I used to do the bedways on the mini lathe, and I'm going to repurpose it to do the legs on this particular build. I've got the fixture down in the vise initially, and I'm using the back jaw with spacer blocks to position the parts on the fixture. Once the parts are positioned, I will extend the parallels up, put the fixture back in, and now I can mill the ends off and drill the holes all in one setup. Anytime you have a part held down with just one screw and you are cutting on that part, you risk what I call a helicopter. That part could grab and spin, unlock the screw, or unloosen the screw depending on what day of the week it is. So I'm taking my time. Just looking for a cleanup from my point of view because I'm looking from right to left here at camera angle. I'm standing to the left of the screen so I can see what's going on the face that I'm milling. I made an adjustment between the parts. I'm coming back to the 0 on my digital, and when I believe that I have a surface that will clean up both of them in one pass, I will make a continuous pass without moving the table in the y-axis. Side milling the pieces like this assures that the top and bottom are parallel and both of these pieces are exactly the same. The 4 small bosses on the insides of these legs are registration surfaces for a tie bar, so I'm going to make sure that they're nice and flat. Setting a stop on the quill, I'm going to come down and I'm going to spot face all 4 of these to the same height. Minimal material removal. Off camera, I located the boss positions with a dowel pin in the drill chuck, recorded the numbers, and I will use those values to center drill and drill the holes in the legs. Center to center, each leg is the same. That way it's going to be relatively reliable when it's assembled. And yes, I'm using a center drill and not a spot drill. Got to be real careful when you're holding castings. You hold it the wrong way and you're going to leave a footprint in it. Ask me how I know. This particular setup is a low impact setup. I'm going to use some parallels and some plastic. Nice clean piece of 3/8 silicone here. Delrin. Double stick tape on the back of it. You can see the white right there. piece in the front is going to go right flush with the jaw. Want to make sure it's flush with the jaw. Pinch a parallel on top of it, press it down before you move it back. Let's see if I can do that without hitting the camera. There you go. A little bit of pressure just to get everything seated. There are two parallels underneath this particular block. You can see the two right there. I'm going to slide one of them out. Now you can see the gap right there between the plastic and the parallel on the bottom. Using the flat side of the part, I'm going to put the flat side against here. That little lip is going to go in that 1/8 hole. And the top is going to close down thus. Two 56 holes coming up in each of the feet. Those will be for securing it to whatever machine shop floor I come up with in the future, possibly leveling feet on this as well. Who knows? Let's set this up for a drill and tap operation. Finish it off. I'm going to use a 125 pin in my drill chuck, and I am going to contact this face right inside here. This overlap here is about 125, and when this pin makes contact with that face, it'll be about in the middle of the extension. I'll visually align it left to right, record the value, cut the other pair of holes in the other leg, the same center line. I'm going to use the exact same setup with the two Celcon pieces for the single hole in the opposite end. The dimension of this hole is given from this front face, so if you're going to clamp it this way, make sure that these pieces are the same left to right, or the hole will be out of location. It's always a good idea to bank your part from the surface the dimension is given from, but in this case, that's just not possible or not practical. So I measured the thickness of the leg, picked up on this face right here, moved out, and then moved the dimension given on the print. Finding the center, you can do it however you want to do it. I did mine with a pin and a piece of paper. And that is all she wrote. Two holes in the front, two threaded holes in the bottom, one central hole in the top, a whole lot of file work. Item number 4, next piece in line. This is called a tie rod. Looks like a miniature cannon barrel. It is tapered 1 degree on each end, cylindrical in the center, and a small ball feature right in the middle. That is a form tool operation for sure. This is a relatively easy piece. There's 2 of them, and we're going to do them end to end. That being said, since this is going to be tapered and that's going to be very small, the most ideal feature to do first would be the ball in the center. You have a cylinder on either side, and that's a whole lot of grip area there. You can flip it around. This is just about 27 millimeters long. Let's do it. Well, I hadn't planned on showing how I was going to make that little bead tool in the center, but let's do it. I'm going to take a tool that's relatively underutilized. I'm going to put a flat on it just about the size of the distance of the feature itself, which is 0.93. I just measured it. Doesn't need a whole lot more to get there. And it is okay if it's too big. So this is what I have at this moment. I'm going to remove the angles on the side so that front of that tool is straight. This could easily be accomplished with a die grinder, but I'm going to finish it with a file. I'm going to finish the feature with the file, not the tool. Let's see what we got. Take a test cut, see how it looks. Once you have your part cut to length, drilled and tapped on both ends, the first feature I'm going to do is this little ball right here in the center. And you just saw me make the form tool for that. It's easy to position the form tool. Once you know how thick the tool is, how wide the tool is, bump the tool against the face of the part, move in half the thickness of the tool, and then move the center line based on how long the part is. Simple plunge operation. And then we can set a stop for the 4 symmetrical features that will need to be formed on the end of both of these pins. So just make sure it's hanging out far enough to get to the center with the tool, and do each piece manually. It's not worth setting up a stop for that. Let's do it. I did not modify the tool off camera. It went straight from the grinder right to this tool post. Make sure I have enough room for everything. Move it out a little bit. Sharp. would say that is close enough for what I'm looking for. Crest is a little high, but it was done on an 8-inch Baldor grinder, so I can't complain about that at all. That is just about 2.5 millimeters across and about 3 millimeters in diameter. Let's cut some pieces off, chop them up. There is a stop set inside this collet, and when I work with a stop and I'm doing multiple pieces, the very first thing that I'll do is face off one end, not necessarily to the stop, just clean the part up. I know all my blanks are oversized. That's a good place to start. Okay, now a lot of you guys are going to be scrambling for the keyboard to try to argue the point of, hey, you have a stop set, why not face all the parts according to the stop? Well, sometimes when you part pieces off or saw pieces off, you're going to have a burr, and if that part registers that burr against the stop inside the collet, well, the part's going to come out short. So I make sure that I have a clean face. If you know you have a clean face, if you have blanks you can trust, then by all means trust the stop. Let's bring them all to length. That will consist of making sure that the part is clean, registering against the stop, taking a test cut, measure it, reinstall it, make the adjustment, set your zeros, and go for it. All right, there you go. Ball is the same diameter as the journals on either side. Now I can choke this up in the collet, holding on the entire area and do the taper work on the end. It'll be a lot stronger that way. Time to reposition the stop inside the collet. Here's the working sketch for the next feature in line. I am going to use a 45-degree form tool to do this. I know somebody's going to ask or be confused, so I'm going to show you how I'm going to do it. I know what the major diameter is. I know what the minor diameter is. Therefore, I know what that drop is. Total. This is a 45-degree angle, so whatever this drop is, that's what this distance is. This land is given on the print. So if I know this land, then I know the distance from the face of the part to that point right there. Using a form tool, it's easy to move over exactly that much and then plunge in the required depth. You now have two features formed. You have your chamfer and you have the 031 blend on the end. This is a 1 degree per side taper according to the print. So using the compound and doing some trig, that's actually not 375, it's pretty close to 375, but I'm staying shy. So I'll crank at 375 on the compound, 375 on the hypotenuse of that 1 degree triangle, that is. And when I get to this end right here, the face of the tool will form the shoulder on the outside of the part. Simple. Bump it, shift, plunge, compound out. Sounds like a dance move, right? Bump it, shift, plunge, compound out. Anyway, once that's done, you have this material left over, the diameter of the ball. Flip it, do the exact same thing on the other side. This should be relatively quick. Let's do it. Camera is positioned directly above the part, basically in the line of sight that I have to cut this without having a problem. But I did do a setup piece, and I know it's going to work. I will not lie to you about that. And when in doubt, have a setup piece. That's not a bad thing to have. To illustrate what I just said at the desk, once the tool registers on the face of the part, move in whatever the dimension says, plus the 45-degree offset calculation. I'm going to run the tool in until I scratch the OD. I'm going to go to my root diameter and taper out. I'm going to do this in 2 passes, strictly for finishing. Here we go. One. Side 2 coming up. All right, let's take it out. Get a closer look. That was real time, by the way. That was not accelerated. I would say that's a win, guys. We have the 45-degree taper on the back side of the front. The small land required on the print. The 1-degree tapers. Now it says 1-degree taper. That is 1 degree per side. 2-degree total conical taper included. That's it. Right there. Not a bad thing. Using a form tool using the compound saves a lot of trouble. Let's continue on, make some washers, and assemble the base. Well, that's about all I got for this time around. Believe it or not, that was an awful lot of work for such a simple looking assembly. Form tool, taper turning, a lot of forming here with the files on the outsides of these if you want it to look good. I made a couple extra brass washers for underneath the screw heads, and yes, I agree they should be hex head bolts, but they're not, so just gonna have to get over that. For now anyway, that's all I got. Thank you very much for watching. Joe Pye here at Advanced Innovations. I hope you come back. Hit that subscribe button. I would love to see 150K by Christmas. That would be an awesome Christmas present, and I would accept graciously. So there you go. Thank you very much. Joe Pye, Advanced Innovations, Austin, Texas. I'm out. Also recently gifted to this channel is the PM Research Shaper Kit. This is going to be fun as well. Although I personally have never run a shaper, I'm sure that this isn't your standard size shaper. This came to the channel by way of Rick out in Illinois, so thank you very much for that, Rick. And sitting right alongside of it, you guys have been way too generous. This is a D10 Stort twin cylinder vertical steam engine. Came all the way to Austin, Texas from the UK. Courtesy of Mr. Steve. Steve, I'm not going to use your last name, sir. I didn't ask your permission, but Steve was gentleman enough to not only send the kit, which is not cheap. This is a very quality kit, extremely large kit. He sent the fittings, he sent all the bells and whistles, the tubes, pipes, gauges, and then above and beyond, sent taps, dies, everything to make sure that I was able to do this, and I will document it for you as time permits. But I'm looking forward to digging into all of this stuff. So it is Christmas in September right here. A couple days after my birthday, and all this is open and on the table. Thanks, guys. Your generosity is very much appreciated. Thank you very much.